So yeah, just to start with some basic information, and then when people come, they can join it. So I respect it. Thanks for joining in. Um, and then if you guys have any questions, just type in the type box, or maybe I'll give you like 5-10 minutes at the end of the session. The idea is that because usually, I do all training, but with this meetup, and I speak at local Microsoft community events. So, so it's pretty much, I've been doing it every month, more or less. I speak at the events, local events, or sometimes international conferences. And I'll be doing one more remote session, most probably first week or 1st or 2nd of April for a New Jersey group about security in cloud or Azure. So that's just wanted to give an idea because it's a monthly giving back to the community. And then other than my job, and I do offer some trainings and all that. But this today is just wanted to give an idea people who are looking or seeking their career or wanted to be in the cloud computing. So Microsoft came up with this certification, which is designed not for so technical, but maybe some people either they're looking for career in cloud computing, or somebody who wants to have a basic idea about Microsoft Azure Cloud, and people a non-technical role. So it does not require any prerequisites. So somebody who needs to understand and want to get a start learning about Microsoft Azure, so it's good. So the way I look at it, if you are in IT or tech, and if you want to pursue a career, so basically with this certification, or even if you don't want to do the certification, which is $100, but again, if you learn the concept, you lose nothing. It's a good value add as long as you are either planning your career in cloud computing, or or you're coming from the developer or programmer background. So it kind of gives you a very good understanding about the Microsoft Azure Cloud. So let me ask in the chat. I think I did in the meetup, but again, let me ask one more. So are you guys already in the cloud, all of them, or no? Just type yes or no. I am just type in the chat box. Okay, Kingston says no. How about the others? Okay, so I think it's then you guys are the perfect audience, or in this session, because it's an opportunity to learn. So the reason I did not put any slide deck, because I just wanted to share what Microsoft has, some stuff available online. So I'll share as we go on in the screen and then the reason I have pulled it, because I'll be explaining. But if you want to self-study, you can always do that. There's a self-study program available from Microsoft. So the main thing is the certification is called AZ900 right now, and sometime in May it's going to be expired, and it will be renewed with some new certification. So it is, we'll see what number they're going to come up with, but that's what Microsoft is doing pretty much with most of the certification. And now they have moved the certification to a role-based. Gone were the days there used to be system administrator, SQL, and database administrator. Now they are changing the certification, the type of the role you are into. So if you're cloud engineer, you got to have 2 or 3 domain expertise and the certification. So which is a new model across, that's fine. So this is a different model across whether Microsoft Azure, Google, and AWS. And I would not be surprised if somebody asked this question, which cloud is better or not. So I'll keep it open for some time, or maybe if I get a chance. But idea is that whichever platform you pick, if you're starting your career, It's really good to know how this cloud works and how much does it different from your on-prem environment or traditional data center. And to be honest, to start with something like this, the one I'm talking about, easy. You don't need a prior experience, and it could be a good start. And you go look for research from Gartner, Forbes, whatever. There are millions of jobs available, especially these days. We are dealing with the viruses, and it's like remote work. So there's an opportunity for the people, because if you look at Amazon hiring 100,000 employees, but not in IT, but as a general, so there'll be more opportunity for the people to work from home. So if you have any kind of cloud skill, in my personal opinion, at one there will be more demand for the people with these type of skill sets. So what you see on the screen, you can also look up AZ900, but the thing what we need to focus here is the exam detail. What areas do they cover? Basically, the concept, you need to know for 20% of that. We'll look into that, what those specific area within the concept. So 20% of the question will come from that area. Then you need to understand the core services. So what are the core services within the Azure platform? And there will be questions somewhere around 30 to 35% of that. Security, compliance, and trust is huge. Again, 30%, but Microsoft do have a separate certification path for the security engineer. If you are looking for career into security, it would be a good start to have the fundamental information, fundamental learning and knowledge by doing this study. And then you can have some hands-on experience and become an advanced level Azure security engineer also. And all the way then you can go to the architect level. And the fourth one is about the pricing and support. This is also very important. Pricing and support, because the cloud model is basically pay as you go. That's like Uber, is just like Airbnb. You pay for the services, and that's pretty much, and if you don't consume those services, basically you don't pay for that. That's the cloud model is all about. So now I'll move on to this slide where it's a self-study from Microsoft. I'll just put the URL just in case afterwards whoever needs to have access to it. So the thing is that here you need to understand the benefits, why companies are moving. So that's the basic level of cloud. You need to understand why companies are moving to the cloud. So it's totally a different mindset. And then people are changing, as I said before, from your pay-as-you-go model. It's cost-effective. There is no upfront cost, because if you imagine, if you were in a position or you go to a company, and usually you need to buy the servers upfront. That's usually happen if you're given a project. Let's say even for if you're given a project, even for a marketing. Because I'll be talking about general examples. So if your company wants to run a TV ad for marketing, for example, so they need to bring servers to manage the load, because when you go viral, so instead of thousands of users visiting your website or Instagram or whatever, for example, there could be thousands or hundreds of thousands of hits, for example. Or take an example for any sports game. So during that time, you need to have a highly scalable solution. If you were to do it today in a traditional model, which is in a data center, what you're going to do is that, okay, we need 10 servers or 20 servers, depending on the size, depending on the promotion, depending on the application. And then what happens once your promotion is done, 3 months later, 6 months later, what you're going to do with those servers? They're gone. You don't need them anymore. You don't need those storage anymore, say the compute and power and all that stuff. So only thing is that this all hardware becomes useless after 6 months. So that's the concept when Amazon started back in days, because they are the one who came up with this idea of cloud computing. So they had the same mindset. So they said, okay, why not we do it something for themselves where they can charge for individual or whatever the compute is. So if I need 2 CPU, if I need 32 GB RAM and all the basic stuff, so I'm supposed to be charged for that amount. Once I'm done, I release that. So that's how it makes it more affordable, and there is no upfront cost because you're not paying. You just pay on the go. You select it. So the thing what I just talked about, pretty much I have indirectly explained to you what is infrastructure as a service. We'll look into that more. But infrastructure as a service means in computing, when you have a computer, even at your home, at your laptop, it has those pieces where it has a hard drive and CPU and all that. But when you go to the data center, you're talking about hundreds of servers. Data center do have storage area network. Data centers, there are routers and switches. So this is all infrastructure. The moment you talk about cloud, um, you would never have accessibility or availability of those physical infrastructure. Cloud, in other term, is the name of virtualization. So I would not be wrong if you look it up. Cloud is virtualization. Without virtualization, cloud does not exist. So you are in the cloud, regardless whichever platform you use, as I said before, Microsoft, AWS, Google, Oracle, whichever. So the moment you talk about cloud, it's all virtualization. So in virtualization, there's a concept for management plane and abstraction layer. So as an administrator, as an IT person, you will get access to that. What kind of machines you want, what kind of hardware you want, all those configuration piece, you will have full access to it. And based on that, all these things work: pricing, how fast and slow you want. So that's how it works. And that's what's related to like a one of the pillars is infrastructure as a service. So we'll look into that. Now it is scalable. What makes this scalable? What is scalability? Um, can someone type in the chat box what do you mean by that? Because I want to keep you guys engaged. And if you're driving, you don't have to type it, but uh, uh, if you're not, then just type in the chat box. Can you define me scalability? You don't have to be a right answer. Just think what does it come in your mind in terms of computing? What is scalability? No answer. Okay, no problems. So scalability means scaling, as you can see on the screen of not a vertical scaling and horizontal scaling. So as I told you in the beginning, the example, let's say if we have take an example for these days, AWS and people, or Target or ShopRite. Now people are at home and they're placing the order for their groceries online. So a week ago, probably this was different. Now a lot of things changed, and because of those limitations, people are told to self-quarantine and stay home. So now the buyer, which used to be on the street or which used to be in this store doing online purchase. So if these companies go back and look at their consumption of the buying on the app, on the website, let's say the average traffic was 50 user in an hour, it must have spiked to 200, 300 users, depending, because everyone is doing shopping online, right? So is their system is designed to, or is it capable enough to take that load? Yes and no, depending, right? Take an example. People are sitting at home these days, working from home and watching Netflix every night because they're working from home, right? Or in the evening because they are saving their hours maybe in commuting. So the user that used to be at 8 p.m. to 10 p.m., 200 or 200,000 people watching Netflix might have gone up 30, 40%. So these are the scenario happens, and this is where you need a system which has to be scalable, where these machines, when there's enough load, it can always scale up and scale out. Scale up means add the number of user, vertically and horizontally. So if you look at scaling out is adding more servers or services. So it depends how these configurations for the application are done. Take an example for grocery or AWS, Amazon itself example, or ShopRite. So if there is a load at the peak, in the back end, the application will automatically scale out to meet the demand, because at this time you don't want to lose the business. So if the 30% usage in the consumer, system automatically add more CPU, add more memory in the back end to meet that 30% demand of that load on that particular hour. So that's the scalability is. And once the peak load is done, after 3 hours, 4 hours, depending, machine will automatically scale down. So scale out and scale down because that time. So with this on-premise environment, I would not say it's not impossible, but the cost of doing that model is way huge because only you as a company using it. But the cloud model is a shared responsibility model. It's a shared resources model. So if you're not using it at 8 p.m. Eastern or 11 p.m. Eastern, when the peak load is not peak load anymore, at 11 p.m. Eastern, it will be then 8 p.m. Pacific time in California and Seattle. And that time, when you release that load, people in that region will start utilizing the service, right? So maybe for another customer. So if they are happen to be on that same cloud model where they are hosting a service, they start utilizing. So you see, it's a shared model. Same thing applies in a peak time for maybe an Uber. When any airline is landed, at that time you see thousands of Ubers around the airport. And if that is not anymore, you don't need. So that's supply versus demand kind of concept. That's the beauty of the cloud. And regardless which cloud platform you use, they all provide a highly scalable infrastructure. So that's very important thing to know. And this is one of those feature which is really good whenever you are into any application designing or those kind of capacity planning. We have to design some applications. So this is where they really play a very important role. And you may hear in the future, which is not part of this course, but Kubernetes and Docker, containerization, and all that stuff. So that's not in the course, but again, just kind of give you an idea about how or what does it mean by a system needs to be scalable. So elastic means, again, kind of the same concept. If you look at a workload changes due to a spike or drop, as I said before, so that is also related to this elasticity, how it's automatically adding on all that. So it's to give an example for the website here. And here, horizontal scaling, we're talking about server processing. Here we're talking about adding more and more memory. So pretty much they're the same concept, but if you need to distinguish between that, it's more of a CPU and memory we are talking about. Elasticity means it's an application layer. If you're running an application, you can have the cloud automatically add resources at the peak hours. So adding those resources at the peak hours is about how elastic your setup is. Elasticity there, it can go up and down, and that's in a nutshell. The system is the scalable and elastic at the same time. Any question at this time, or are we good? Okay. So move on to the new one. Okay. So now it's current. Okay. So in this thing, the biggest challenge has ever been IT is about system updates and patching. Even you have a computer at your home, a Windows or MacBook, basically, you would get those Windows updates and MacBook updates every month, if not every week. So system needs to be patched all the time. Otherwise, there are vulnerabilities. System is vulnerable. It can be hacked. Even your phone needs to be updated. You update your iOS every time you get an update from Apple or maybe an Android. So that's the software lifecycle, regardless whatever application, whatever platform you use. You got to make sure the system is up and running and up to date. So imagine the company you work for may have 300 people and 300 desktops and laptops. How would you deal with that? But there is a dedicated IT staff who does that. And that's not only limited to that, but if you have an application and if you're in a retail business, then you have to think about which time of the day, because you cannot bring down a server for patching during business hour. And if you're an international company, your operations are 24/7. How are you going to deal with that? So there are challenges and challenges. So of course, there are different ways of doing it. It's not nothing new. But when you go to the cloud model, where cloud provider takes the responsibility of pretty much most of the stuff, as I mentioned before, IaaS, and there are two other different delivery models. We'll talk about PaaS and SaaS. But imagine when you go to the cloud, everything is virtual. And when you go to the cloud, you do not have access to any of the hardware. Means you have access to the servers where you can select, hey, I need 4 gigs of memory or 32 gigs of memory. I need 1 terabyte of hard drive. I need this server. So you can tell the specification, but you don't really be able to touch that hardware like you do at your home. You can touch a computer or physical asset when the cloud is not. So, but the beauty is that all the underlying hardware which cloud provider is providing you is basically their responsibility and they are managing it. So it's a peace of mind, in my opinion, because that's the beauty I like about the cloud, is that you're not responsible for any underlying hardware management, because that's not limited to the server itself. The server, the storage, the network, the firewall, the routers and switches, you name it, whatever it takes to run that infrastructure, even in a company size 50 or 100 or 300 users, whatever. The more bigger the companies are, more bigger the infrastructure and more complex. But these are the all things you need to think about. So when it says current, your hardware, underlying hardware needs some patches and system updates, even operating system updates or firmware that is staying up current. And when you go to PaaS and SaaS, you will see it keeps on changing the more different layer of the cloud or delivery model you go for. And we'll see if you want to run some SaaS application, so the model is different. We'll look into that. Reliability. So reliable, let me just read that, because how they're explaining, okay, so they're talking about data backup, disaster recovery, replication, and all that. So let's take an example for data backup. So if you say infrastructure as a service, I talked about it. I talk about PaaS and SaaS. So switching a gear a little bit, just to make sure you understand better. So if I tell you if you're using an email from Microsoft Office 365, or if you're using an email from Google Apps, or maybe Gmail, which is consumer-based version, or maybe Microsoft Outlook, do you think you ever need to worry about taking backup? No, you never, because it's a consumer-based product. And even if company is not having their domain .com, email name as .com, the company name .com, but if they're using any regular Gmail account, nobody cares about the backup. So same thing if a company or education institute and university college, they have .edu or .com email, and they host their email system either on Google Apps or in Office 365, they don't have to worry about backing up anything. However, if they do it today in traditional data center model, they are supposed to doing the backup, because not only the legal requirement, what if their system crashes? It's customer data, or may they have some business email where they may have some sales order, purchase, whatever the detail related to the business. If they do not have a proper backup due to some virus or anything, they can be out of business next morning. But when you go to the cloud, you don't have to worry about that. So as a business person, you focus on your business and then let service provider or cloud provider take care of that. So that's what in a nutshell is about, how the system is reliable, because they are responsible for that, not only to back it up, but also making your data secure. Your data is encrypted in the cloud. If you have a disk at your home, if it gets stolen, it's clear text. So same thing, if somebody is running their manufacturing company, if they have the server, they do not have encryption, it's vulnerable. But if you go to the cloud, it's by default encrypted, backup you don't need to take, so all that stuff. Same thing applies to disaster recovery. If you're a company or a bank, and if you're in New Jersey and you have a data center in Secaucus, but you have a confidential data, you're running a business, it's a bank. What if something goes bad due to flood or earthquake, whatever? You need to make sure you have a site B. If the site A has an issue, you go to and flip it over to site B. So basically, in that scenario, companies already have their data center. But when you go to the cloud, there are some basic native features, or there are some service available which can give you immediate availability of your website from the second data center. As I said, if I take an example for Google Apps email or Microsoft Office 365, you don't have to really care about it. Your email is up and running regardless, whether it's from New Jersey or California or any part of the US. You're still running. And it's a global company, so they have set data center even in the global, so you don't have to worry about even it happens in one North America has an issue with the fiber optic cable. You may have some disruption, but you're still business up and running. So that's the beauty, and that's why it's more reliable. And global part, which I already covered it, because Microsoft, I don't know, top of my head, they have regional locations, more than 35, 36, I believe. So every last few years, they've been opening so many locations, geolocation, and the importance of a regional location is that whether it's a Google, Microsoft, or Azure, because if I'm in US, I want my email, my databases accessible in the locally. So if I set up those environment, and I decide, hey, I'm based out of somewhere in New York metro area, so I want to make sure my data is accessible within one of these local data center or regional data center, which could be in Virginia or I don't know, one of these locations. Versus if somebody's in UK, so in Microsoft, I believe they have a data center UK or in Ireland, like a regional data center. Same thing applies with the AWS and all that. So I don't want my user to accessing their email coming from all that from Australia to New York, because there's a lot of round trip and latency on the over the wire distance. So that's kind of concept you're talking about. Why it's global? Why do they have to do? And there are some compliance requirement, legal requirement from GDPR and all those stuff. So that's another area. But that's being said, being global, it meets all the requirement, as we see, as he's saying here, data residency and all that, but also the availability of the service. Now I'm going to talk about today is also about the security. As I mentioned, a couple of ideas before: data at rest, data encryption at rest. Physical security is very important. So even in these providers, even their employee cannot just go and access, because they have a multi-layer of security. So imagine if you work at a company or whatever, a small size company, they usually have a card reader. You go in there and access to the server room. In this company, it doesn't really happen like that. And pretty much most of the stuff is remote. Only people need to go when they have to change physical hardware. So you can read online. I don't have the details, but again, the idea is that not physically secure, but also whatever you need to make sure data is secured digitally. And that's why we have encryptions and all those technologies available there. Data at rest, in the transit, multi-factor authentication, and all that stuff. And there are more in detail, but to kind of give you an idea, is by design. They have all these things physically, if you can see the cameras and gates, whatever physical security you can think of. But beauty of the cloud, you need to understand the concept about virtual or digital security, right? So whenever you set up those servers, even in the cloud, like I talked about software as a service, which is SaaS model, Google and Microsoft 365, you are not accessing an individual server. You are just given a web interface. That's it. But in the back end of the web interface, there are hardware and software, but you really do not have any access. But same thing, if you run an email system in your office, you can physically go and plug the hard drive. So that's totally changed from traditional data center model cloud to the cloud, which is a SaaS. Also, if you have your machines, which we're talking about virtual machines, which I said in the very beginning, everything virtualization. Even for the virtual machines, when you go and set those up, they're secure by design, and they're not open for everyone in the cloud, and you can apply different policies to even take it to the next level. But that would be beyond of these course, because this is a high level conceptual idea to give you, okay, why and how it is different, why it's a different idea from on-prem, because companies have invested a lot on the data center, but every 3 5 years these companies need to upgrade their hardware, which is what we call a refresh, like a car. If you have a car 10 years later, you need to change the car depending how you drive, but it's still you need to do a regular maintenance and oil change and all that stuff. Same thing applies in IT also. Every 3 5 years you want to change. The reason is that if you don't do that, and if you're running a very old system, then you will have compatibility issue. Your application may not compatible what you have done today after 10 years. And then what's challenging is in the business, because then you won't be able to stay ahead of the business the way things are. So if the company is running an application, I don't know, maybe a banking application which does not have those tools and capabilities the way we do banking on our cell phone, and they're running a 20 years old database, that's a challenge. Same thing, example for the Instagram and Kodak, how they make APIs and all that. So it's a difference. So that's the reason the company needs to keep updating. So that's the reason they need to be on top of the technology. And that's one of the reason the transition to the cloud also. So every company, they do their homework. Cloud is not about just saving the money and adopting the cloud. There are many reasons. More homework is required. But if you say if they're a smaller company, let me put a number size, 50 user company, then it's a no-brainer. In my opinion, they just go to a cloud environment and focus on the business, and they do not have to worry about any backup and security and physical security, any of these. They just pay as you go. The beauty is that today you have 50 people. For some business issues, if you have 40 people, so you don't have to pay for the 50 licenses you pay. If you increase your workforce from 50 to 100, all of a sudden, you don't have to go crazy and buy more servers and all that stuff. It's a pay-as-you-go service. You give them the features, the tool, the technology they need right on the go. And next day, you can tell your CTO or CIO, hey, I have this environment, so we can accommodate from 50 to 100 people, and you can also even tell your HR, right? So that's the beauty. That's why the cloud is really good. It's scalable. It's available. It's elasticity model is there. So that's, I think, I'll give you like if you want, I can keep continue. But again, any question, do let me know. Type it or unmute your speaker, and then I'll proceed accordingly. Yep. Anyone? You good? Okay. So far so good. Okay. So I'll do it for another 10-15 minutes. So let's talk about some compliance. So I do a lot of compliance, but really I have not read about the theory itself. So what we'll see, because there are so many tools and technologies available within that, and if you look at on a high level, because for every cloud provider, they have to meet industry standards to be compliant. Okay, so before we go into that, where it's coming from, that's why you need to understand. You can, of course, you can go and read it. But where's the need? Where's it coming from? Why do we need to be compliant? That's the question. Everything is about the why. So when you are on premise, so you need to understand whether you work in a retail industry, or even if you work for a pharmaceutical, or maybe you work for a law firm, a bank. So if you look at all these three verticals, you need a different requirement, because if you work for a hospital, hospital, the data needs to be HIPAA client. Like uh, if you are into the financial, then there are some financial industry related compliance from the available. Like there are some standard ISO 2700 and also from NIST, which is the federal control, and some other, as you can see on the screen also, GDPR is European standard. They implemented last year. HIPAA, as I told you before. Then high tech is another additional form of HIPAA. All these standards. So why do we need to do that? The problem is that whenever these banks and everyone is running on premises, it's just like they control it physically, right? So they know that somebody needs to go to the data center, they need permission. Even virtually the servers are on the internet, somebody can hack, they don't care. But at the same time, they are physically, so they feel so comfortable. Hey, nobody can access this server because we own it physically on our location. So that's the concept. But as soon as you make a file or anything into the cloud and without knowing these compliant requirement, those companies can be sued. So they have to make sure whether which platform they choose, AWS, Microsoft, Google, do they really meet those requirements? So I'll give you an example. If a hospital decides to go online, the hospital is keeping that data for their patient, which is in their data center running on maybe one database server and has personal information, my record, my medical record, and all those history. So if that going to be in the cloud, is it really compliant or not? Because then somebody can steal it and sell it, and we see these breaches every day, every week. If you look at it up, and these breaches are in millions of records, 100 million records stolen, and all that. So when you go to the the cloud, you have to make sure, and pretty much they all cover that. It's not just Microsoft; they all meet the compliance requirement. But those compliance requirements are that, hey, if I'm going to the cloud and if I'm a US-based hospital, then I should not be hosting my cloud data in UK, because when you go to the cloud, you need to know the location, the region of your data, everything. So this is where you need to understand and do homework. So that's just one piece of it. And then when you look at these certification, they have put it like each and every certification, ISO 2700, and they have their more control in each and every standard. Like GDPR is related to people who live and work in Europe. And if I'm a US-based company, so technically, I have some legal boundaries, so I should not be collecting and processing data. So there are like details around GDPR as well. And so because cloud is like international model, so you have to be very careful in that. So that's what it's saying in this. You don't need to go in the weeds of each and everything, but you just need to know the top. Okay, these all compliance offering are available in Azure: Star Compliance, GDPR, EU model, HIPAA, HETAC, ISO standards, multi-tier cloud, which is Singapore. I don't know, something new came. And so there's a list of that. So you pretty much, in my opinion, will have to memorize it and understand what those are. But on a high level, you don't really have to go into the weeds of any of them. So we'll go to the next. Economies of scale. Okay, let me read that. It's I kind of explained you in the beginning. So what it says that is the ability to do more things efficiently at a lower cost per unit when you're doing a larger scale. So to give an example, if you need to, let's say, do uh, some work and you need to deploy a 500 server. So on an on-prem, it could be millions of dollar project. But if you go to the cloud, you may be able not to do 5 million. Maybe you can get done with that, $1 million. Same thing when these. So it's an example of one company. So this cloud provider came up with an idea. Okay, like Microsoft, Google, why not leverage all these businesses and give them that platform instead of one company doing itself? Let's build a platform where they all can utilize. So that's why we call it a shared model, right? A shared cloud is a shared model. And with respect to security, it's called shared responsibility model. We're not going to security now, but it's the shared responsibility model, basically. So these Microsoft, Google, and Amazon, they have maybe millions of servers physically all over the world, and each data center size is big as a football field. So imagine how big those are, and that's why they achieve economies of scale. It's a huge, humongous, thousands of servers um, across the world, and this is where it brings the cost to a much lesser price with state of the art feature and capabilities. The more you explore the cloud, the more you will be surprised. Even I'm in the industry for pretty much 20 years, doing cloud for the last 8-10 years, and still I'm fascinated because every time there is some new thing available. Excuse me. Sorry. So that's in a nutshell that they are able to pass on those benefits to end user and consumer, because if you look at they are coming with these new capabilities in the software, the features, more controls, and that's why they're able to do that. So that's how they achieve it and bring the price, because it's not about compute cost, the storage, it's a network, it's security, all strings attached. And now the next topic is talking about, this will be the last topic for today, tonight, is CapEx versus OpEx. So have you heard these terms before? Can you type yes and no? Anyone else? Yes and no. Have you heard these? So okay. So let's just keep it here, not to go technical. I'll give you a real life example. CapEx and OpEx is capital expenditure and operational expenditure. So if I were to buy a car, take an example, Kia, Hyundai, Toyota, Tesla, whatever. So when I going for financing, not a financing, when I'm going to buy a car, if I have $10,000, I said, okay, I need a car for my daily commute, for my work. So I'm putting that upfront cost. And then for the next 5-10 years, I think I'm fine because I want to keep this car for at least maybe, I don't know, 10 years. It will run based on the homework, market research, the mileage this car has, blah, blah, blah. So I put upfront $10,000. So that is a capital expenditure because I'm putting all that money upfront cost. And what's going to happen 10 years later, that 10,000 cost, if I were to sell it, would not be sold for more than 2,000 grand, right? So over the time, there's a depreciation. So that's a capital expenditure model. Same thing if you buy a laptop today for $1,300, 5 years later, if you were to sell it, may sell it for $200, I guess. So that's the capital expenditure, means always upfront. So that kind of makes sense when you're doing these kind of transactions. In laptop, fine, maybe not. It depends. Because and then it's up to you how you decide. And same thing applies in IT, because now the second model is operational cost, means pay as you go. So think now, step back. If I have $10,000 and if I just need to go to my work and come back and nothing else, and maybe I'm traveling, or for example, I do not need the daily usage of that car. And I think in my situation, in my circumstances, I think I don't need this car this much. I think I can live with Uber. So a $10,000, I can save it and invest somewhere else, but I'm not needing that car every day, maybe twice a week. I think, okay, then I can afford Uber because Uber costs me $100 or $50 a week, or maybe I'm just doing the random number, not doing the actual math. trying to explain, okay, it cost me this much, which is much, much less, $200 a month. In a year is $2,000 to $400 versus $10,000. You see what I'm saying? Same thing, same applies to this CapEx and OpEx. When you go to IT, and I gave you an example, if a company were to buy or do a project where they need 500 servers or 100 servers or 100 server equivalent compute, why would they buy 100 HP server or Dell server? First, they will not be available right away. For 100 server or something, this number of servers, nobody keeps in there because they're expensive. So they will take an order from you and may take 3 months. So you're down the road 3 months already late. And then you're paying this upfront cost, and 6 months later, a year later, you don't think, okay, project is done, we don't need this server anymore, and you cannot even sell them. So 100 server cost maybe, I don't know, $500,000, whatever the number is. Versus if I were to use this cloud model, it's an operational model. So you pay as you go. Same thing I talked to you about Office 365 email. You pay per user, and you don't need it. Okay, your project is over, shut it down. So there's no upfront cost in the operational model, and you pay for the service. And a good example, Airbnb, Uber, these kind of example, which is non-IT. But again, in IT, you want to leverage any one of the cloud provider and use those. So now if you look at on the screen, or if they were talking about server cost, storage cost, network cost. I can cover more in detail what are those, but again, on a high level, when you say in tech, when you say in cloud computing, we're talking about these things because I need to build my application. So what thing is going to cost? Because cloud is a consumption model. So if you're using compute, which means a compute is a processor, and then the memory itself, and then there's a cost for the storage, there is a cost for the network and all that stuff. So when you set those up, every provider has their pricing model available, and then tell you how much estimated bill, or you can pull the report every month and see how much is the bill for that particular utilization. But that's on the compute. But again, if you use a SaaS service like Office 365, you know that the cost of the mailbox, for example, a business plan, 100 GB mailbox, 1 terabyte, one drive of business, which costs maybe even is, I don't know, $12, $15 a month. So you know that there's a fixed price for that, but it's a pay-as-you-go model again. So pricing is different versus infrastructure as a service for Azure, where you have compute, versus those services in software as a service product. So we can look more, if there's more interest, we can talk about more in the upcoming online sessions. But again, this is where the beauty of the cloud is. You don't have to have thousands of dollars if you're a startup. You don't need $10,000, $20,000 just to spend on the compute. Literally, you can start with $500, $1,000 from the day first, and then you keep growing. You keep adding more and more depending. So it opens a lot of opportunity, not for the tech people, also a lot of businesses, university, colleges, proof of concept, you name it. Even for my labs, I used to have those physical labs. Now I do all my labs in the cloud because I know that if I don't need it, I can shut it down and I'm good. So that's in a nutshell the concept about cloud itself, and also I hope I can give you a very good idea about the Azure. But again, that's just the first few chapters. There's a lot, but a lot in a sense, theory and conceptually you have to understand. But the beauty of this certification career path or this particular AZ900, you don't really have to go into the weeds on everything. You are not going to be asked for a question how to configure a network IP address or how to configure storage. No, your role will be like a manager role or something who is not techy but want to deal with those. So there are different. So let's say if you're doing the billing of an Azure, right? So it doesn't mean you have to be an IT expert to understand the billing, right? So the person who works on the billing of this cloud to understand, okay, this is how much I'm paying for the storage, this is how much I'm paying for this compute. So yeah, that's kind of information or basic understanding of the Azure cloud you will understand. And it's good for people for non-technical and technical as well. So I think if you have any question, I'll keep the floor open, and if not, then thank you for time. I'll just be silent for a few minutes. If any question, let me know.
Yeah, no, I have a question. To get into Azure field, do we need to have much knowledge on networking? Because I work as a programmer.net. I want to get into Azure.
No, not at all. It's officially here. If you see my screen on Microsoft, it's officially say you don't need a prior prerequisites, no prior even experience. No, see, if you look at my screen, nothing. And that's the beauty. Somebody who is coming from a different background, who is the programmer or who is a technical manager, right? So if you want to be into cloud, that's the best way to get into it, to understand on a high level. Of course, you need to know the networking, but nobody's asking you what is a router and switch, how to configure an IP address. Absolutely not. Yep.
Yeah.
So if no more questions, so I have recorded this, pretty much going to be putting on my YouTube channel sometime next week. If somebody want to go through it, and I plan on putting some more, maybe I plan on something on a SaaS Office 365 related. They also have a fundamental course, so I'm planning to do that, the same session on that, so kind of give a flavor to people to understand and help them which way they want to go. But it's all fundamentals are good. I strongly recommend in today's cloud is in the tech industry. If you don't want to be tech, but again, kind of have a idea, it's really good to have on your resume, and that's it. That's being said, thank you everyone, and I'll put the recording and I'll update the URL. Thank you.
Yeah, thanks.
Yep. Right.